Today we're going to solve a physics problem that combines both simple harmonic motion and some math applications to attempt to model a dancer's turns. So our question reads, a dancer's turns can be modeled using simple harmonic motion. Ella starts a turn sequence facing the audience with her foot 2 meters away from the back of the stage. In a piece of music that is a count of 8, she turns 16 times. Her turning leg is approximately 0.7 meters long. The first thing we want to do to approach this problem is to draw it out. So Ella's turning, and her legs will both go to the front and the back, but her turning motion will be a circle around these two radii. And then we have the audience in the front, and she starts her turn with her foot facing the audience. There's also the back of the stage behind her. When she does a half rotation, her foot will be some distance away from this back of the stage. When she starts the turn, her foot is 2 meters away from the back of the stage. So 2 meters will equal to 2 of her leg radii plus this some distance x. So x will equal 0.4 meters. A asks us to find the period, angular frequency, amplitude, phase shift, and vertical shift of Ella's turning motion, which is similar to simple harmonic motion. We know that in 8 seconds she turns 16 times, meaning her frequency is 2. Therefore, her period is 1/2. And the angular frequency would be 4 pi. The amplitude would be equal to her radius at 0.7 meters. You could plug in values to find the phase shift. However, because we know that she starts her turn the farthest away from the stage, facing the audience, we know that she starts at a peak, and thus the phase shift must either be 0 or 2 pi. So we model using a cosine function. In most of the functions we've seen, the vertical shift has been 0, as the equilibrium rests on the x-axis. However, in this function, as we're measuring the distance away from the back of the stage, the equilibrium will not be 0. Rather, it'll be the distance between Ella in the center and the back of the stage. This will be the sum of the radius, 0.7 meters, and the distance x, 0.4 meters, totaling 1.1 meters. Part B asks us to write what we found in an equation form, where y of t represents the vertical distance of Ella's foot to the back of the stage. All we have to do for this question is plug in the values that we found. For the final part of the question, all we have to do is determine where Ella's foot will be in relation to the back of the stage at this specific time. Once again, let's draw a picture to visualize. Ella will be in the center, and the dancer will be somewhere in between Ella's circumference and the back of the stage. We know the second dancer's distance to be 0.8 meters, so now all we need to do is find Ella's distance. So all we have to do is plug in this time into the equation that we wrote earlier. Next, we can just plug in these values to our calculator to determine Ella's distance. We find that Ella is 0.88 meters away, which means that she will not hit the second dancer, as she's further away from the back of the stage at this state of the turn than the dancer running behind her. Thanks for trying to model Ella's turns with me. I hope you enjoyed.